So welcome to Gray Associates Masterclass 4, The Future of Academic Portfolio Evaluation and Management. I would like to introduce Gray CEO, Program Management Expert, and Bestselling author, Bob Atkins. Today, he will be joined by Rachel Chung, Mason School of Business at William & Mary. We're very excited to have her with us today. During this session, our presenters will look at how artificial intelligence, machine learning, and other new technologies provide more insight into what makes a successful academic program. We will show how using these tools in academic program planning and management can benefit your institution. We do encourage you to ask questions, so please take a look at the bottom of your Zoom screen. You can click on the Q&A and add your questions there. We will get to as many questions as we can during this session, and we'll follow up later with you if we run out of time. We'll also send out a link that will give you access to a recording of this session, as well as the session slides so you can review at your convenience. And now, without further ado, I will turn things over to Bob.
Good afternoon, everyone, and thank you very much for joining me today. It's a pleasure to be talking about the future of academic portfolio evaluation and management. It's an exciting topic, and I think there's a lot that's going to change here over the next few years as folks both catch up to where the systems are today, and then we take the systems to a new level for you so it's easier to use and more insightful. As mentioned, Dr. Chung will be joining us in just a moment. We're having a little bit of technical difficulty to get her in, but she should be here momentarily. So let's start a little bit with where program evaluation has been, and in many cases still is, an inconsistent, time-consuming, incomplete, and often politicized process. What are the problems we see here? Inconsistency, one aspect of that is the topics and data sources vary from one program analysis to another. One professor may fill it in one way using data from the US Census, another may fill it in a different way using information from a survey of students. And in the end, when you put one program evaluation next to another, it'd be very difficult to even do a valid comparison because the data itself is different. The topics covered may be different, and it's a labor of love for the faculty member who did it. They're burdened with pulling all this data. Often they're unfamiliar with the sources. They don't know the problems with the sources. They may or may not have any experience with large-scale data analysis. They're certainly busy and pressed for time, and their real focus is on the trends in their discipline, which may or may not align with what employers want or what students want. So it can lead you, down a path that's very healthy for a department and the topics covered, but not necessarily healthy for the economics of your institution. And all in all, the work is too time-consuming to do it very frequently. So it's likely that your markets will change faster than your program evaluations, which is concerning. You can really fall behind. Another thing we've seen over the years is an overemphasis on labor market requirements and predictions. The first problem with this is that what employers want and what students want are more often than not quite different. There's no more than a 30% correlation between the volume of employer demand and the volume of student interest as we observe it in our system. So be careful. Just because employers want you to set up a program doesn't mean any students will show up to take the program. The second problem that's inherent there is a very weak linkage between programs and occupations. There is exactly one occupation out there that has over 75% of its graduates go into the field for which they're directly prepared. That's nursing. 80% of your programs have fewer than 20% of their students go into fields for which they're directly prepared. So rough numbers, 80% of students are going to go into something that you wouldn't recognize they've been prepared for by studying in a given program. For example, history majors become CEOs. Philosophy majors become coders. And those both are in the top 10 of occupations for those graduates. The other problem is that people focus in on the predictions, particularly the Bureau of Labor Statistics predictions for occupational growth. That's a bit troublesome because 80% of those predictions are off by 50% or more. So it's not quite throwing darts at a board, but it's pretty close. And I don't think you're going to get a lot better because it's very difficult to predict the future of labor markets. Just imagine trying to predict what would happen in labor markets during COVID. So I think we have to recognize that those forecasts are an element of a program evaluation, but shouldn't be overly relied on when you're doing those. And then we have this problem fundamentally that without good, reliable data that everybody agrees is the appropriate way to evaluate a program, we get to what you might call the loudest voice, but the most politically powerful voice, the wealthiest donor, et cetera, wins the battle over what programs to stop, start, or grow. That's a very unhealthy outcome for the institution. Can often lead to programs that don't align with labor markets. Graduates come out, they have no jobs, or it may lead to programs with no students, which is very expensive for the institution. So we need a better way. And let me, introduce that's going to be dashboards. But even here, you have to be careful, because I think when we start to collect data, and what we'll see in the future is a lot more dashboards, but often uncurated. They're going to mix up exploration of a given topic and the data you need to make a decision about that topic. And most importantly, they often require familiarity with systems that people don't use very often. Particularly program evaluation is not something you do every day. And as a result, when they dive into these systems, they're going to have difficulty navigating, get frustrated, and potentially leave. So where's this going? We think there are a few dimensions to it. One, program evaluation is going to get broader. We're going to include data on markets, economics, skills, demographics, and other topics, international student demand, for example, as a routine part of program evaluation and management outside the building. Inside the building, we're going to want to keep track of diversity, equity, and inclusion, and make sure metrics about that are included in program evaluations. And we'll cycle back to that and talk about some of the variations we see and how that can be managed. In addition, we're going to shift from historical measures to predictive measures of things like enrollment, what future economics are going to be for a program, the degree to which that program will retain students, and other variables that become predictable if you have the right data and you can apply some AI tools to them. But importantly, we're also going to be pushing that data out to folks. We'll be providing reports on what happened historically. We'll be providing alerts about things that are happening, if you will, right now that warrant your attention, and providing predictions about what's going to happen in the program in the future. Those reports are going to be custom to the individual, so they'll be different from one dean to another, for example, and they'll be delivered to them at the time they need them to do program evaluation. Or they may be delivered more frequently for very specific metrics like changes in Google search volume for a program, so people can begin to anticipate enrollment for, let's say, next fall, well in advance, and adjust their staffing and schedules accordingly. So it's a very different environment. You're not going to be hunting around for old data in inconsistent formats through a series of dashboards. I think you'll be getting predictive reports and alerts that are current and tailored to your particular position. Very different environment than most people are living in right now. As part of that, and if you've seen this before with us, I apologize for that, but it is the heart of what we do, and we believe the heart of any sound program evaluation is actually having a program evaluation system. And a system is more than just data and software. It has to include the right people and process in order to get decisions made effectively for your institution. There is data required, however. The first part of that data is information about markets, because in many ways, a market drives what happens inside your institution. If students aren't interested, they're not going to come. They're not going to take the programs you want. If employers don't hire folks, that's going to damage your reputation and ultimately your enrollment. So markets are a central part of it, but they're not everything. Markets drive margins, and margins help you understand how to manage the portfolio of programs you have and the underlying web of cross subsidies that are needed to run a higher education institution. That's a complicated way of saying that high margin programs fund lower margin programs. And that's perfectly appropriate as long as those programs are aligned with the mission of the institution. And then you, of course, have to look at the academic standards for an individual program and include that data. Are students actually graduating from the program? How many of them are getting D's, F's, and W's? Do you have an issue there where you're not teaching in an appropriate way to educate the students that you've attracted? But you have individual gaps in a given course where something's going wrong in the middle of your program that you need to address. And finally, of course, mission. What is it you're trying to accomplish as an institution? And are the programs that you offer aligned with that mission? But all of that's for naught if you don't involve the right people and the right process to make program decisions. Cramming down programs in the president's office doesn't work. Hiring consultants to give you the answer doesn't really work. You need people to help facilitate this. You need the right data, but ultimately it's up to the faculty and administration to make these decisions and decide what programs to start, stop, or grow. A new dimension to this in the last few years is equity. Most folks don't actually include equity in their program evaluation process, but every program has a distinct demographic fingerprint, a specific group of people by gender, by ethnicity that tend to take that program or tend not to take it for that matter. So as you pick programs, you are unconsciously changing the demographic makeup of your campus. So we think we need to bring that into the foreground and include diversity, equity, and inclusion metrics in the program process so that we shape the campus of the future with equity in mind. Now, when you're trying to make these decisions, there is a host of data you could consider. We would suggest assembling it all into one page, and that's how we do it. If you want to do it different, if you might pick slightly different variables if you're doing this yourself, but try and get it down to a page so people are evaluating dozens of programs can look in one spot and not have to hunt over dozens of pages or different documents in order to find the information they need to understand the attractiveness of a program. We would suggest you start outside the building with a scorecard that measures the attractiveness of the market for that program. And when we do that, we think about several dimensions. First is student demand, as I mentioned. And within that, we'll collect data that's future looking. Google search volume, for example, will tell you what people are looking for who are going to enroll 3 to 18 months from now. What's going on internationally, what new student enrollment is showing you. That's very current data. It shows you in our systems, we're up to date through last spring, and you can really see what people are actually taking. And then you look at iPads to get a comprehensive view, but remember that it's a very dated view. iPads is going to be looking at data that's roughly 5 years out of date in terms of what students want. The most current report is 2021, but that report reflects what people chose for their major 3 years before or 5 years before 2021. So really, it's backward-looking data, not forward-looking data. For the future, again, you sort of think of it coming down the funnel. Google's really top of funnel, what people are going to want in the future. Enrollments, what are they doing right now? And iPads will tell you what the historical trends are and what your competition is as well. It's very helpful. Now, then we look at employment, and that's a very conscious order on our part. I think these two are roughly equal in importance, and you want to look at them with the similar weightings, and that's how most of our clients end up doing it. You'll notice as we walk through the scorecard that there are all sorts of colors on the page. Those are not random. They're actually set up so that they reflect the percentile rank on any given metric on the page. So you'll notice here I have dark green for size for direct prep jobs. That's because it's at the 98th percentile, that it's in the top 2% of all the programs we keep track of in the given market that we've chosen. In this case, we're looking at 1,500 programs, and so this is one of the top 30 programs on the volume of job postings. That percentiling and color coding allows you to interpret raw data like 287,000 job postings. You might well ask yourself, well, that sounds like a lot, but I don't really know how many job postings there are in the United States and whether that is a lot, but the percentile tells you the answer to that. So it gives you critical context and understanding information. And I will say, as you look forward and you have more data and you're using AI and so forth, that making sure you have that context is a critical part of evaluating programs and making other decisions as well. So keep that in mind. Percentile is a great way to do it. You may not choose to evaluate 1,500 programs. I wouldn't be surprised if that's an undertaking you want to stay away from. But what you can do is pick programs of your own and pull the data for those that you can make comparisons either to all of your current programs or to one or two programs you want to use as benchmarks so you can interpret the data you get. One thing we're going to be changing, the world here has been looking at direct prep for a long time, and direct prep is basically a myth. Direct prep is the way the National Center for Education Statistics aligns jobs with programs. The problem is that that's not what actually happens in the real world. As I mentioned, history majors go into 500 fields. NCES would only map them into 5. So as you look forward, you're going to want more robust evaluations of what the job opportunities are for your graduates, not the kind of thing you'll typically see in labor market data and other sources that rely on NCES. And be careful if you're doing this yourself that you go broader than the NCS crosswalks when you're understanding what graduates of your programs may do. And finally, you got to look at competition and understand who's out there. And in particular, find metrics that tell you about saturation. Every program is competitive. That's not an issue. And in fact, you might not want to go into a program where there's no competition because it suggests the market size is probably small and it's relatively risky if there's nobody out there who's done it before to use as an example and as a test of the market, if you will. So the metrics we choose are Google cost per click because people bid for clicks. So the higher the cost per click for keywords that are associated with that program, the more competitive it is. And then Google's kind enough to publish a competitive index, again, for keywords that are related to this topic. And that is a 0 to 1 scale. You can see in this example, it's actually not terribly competitive, 31st percentile and a 0.29 ranking. So it's that competitive intensity that you really want to watch out for, not just competition. As I said, there'll always be competitors out there in any reasonable program. And finally, you want to get to demographics.
Bob, can I ask you a quick question before you move on? To what extent should current students be consulted in these decisions? Do they have insight that even if it doesn't benefit them, will benefit the next generation of students?
I think there, let's think of that in a couple of buckets. One is what I would call program assessment. In program assessment, student input is extremely valuable because they'll tell you how your current program is doing, whether it's being taught effectively, whether they're achieving the learning outcomes you intend, and so forth. When it comes to program evaluation, that is, should I start, stop, or grow this program? Current student opinion is much less useful. Typically, you're trying to attract new students when you launch a new program, for example. So understand the students you want actually aren't at your school, ideally. They're new students that you'll attract with a new program. So that limits the value of the current student input for at least new programs. And for growth in programs, it could be useful. You'll often see it. The enrollment will be going up. So you have a pretty objective metric that there's potential. So it's not that it's not at all useful for program evaluation, but it's much more useful for program assessment rather than evaluation. Now, if you're sitting on top, if you're a provost, for example, or even a dean, and you've got dozens or hundreds of programs to evaluate, you need some way to figure out where to pay attention. So we would suggest that you build what we call program management dashboard. This puts everything about a program on one page, both the external data as well as internal data about the program. It contains an overall evaluation. In this case, it's sustained. This program's fine. Keep doing what you're doing. It includes summary data from markets. It includes data on the margin from that program. So you understand what the revenue cost and margin on revenue minus your instructional cost, which equals margin, how much that is and whether it's healthy for the institution. You need academic data here, as we talked about, and this includes things like how many students are actually in the program, how many student credit hours you're teaching, what is the withdrawal or D, F, or W rate for that program, and other metrics like are we passing the relevant licensure exams post-graduation. So in addition to that, you want to be able to cut it by demographic, so by gender, health status, and ethnicity, so you can see if any groups are falling behind. And then you need some good overall metrics on the size and demographics of the program. And finally, the faculty input here. What's the mission of this program? How does it align with the mission of the institution? And what are the goals? And actually, we would suggest below the sheet in our systems, you can actually see the actions associated with that program and see whether people are current and getting done what they plan to do, or whether you're beginning to fall behind. So again, getting it onto a page is helpful so that someone reviewing this can very quickly look at it and understand whether the program's healthy or not. And if there are issues, precisely where to look. If you're standing back at a dean or provost level, you've probably got to look at dozens. So here, it's helpful to have a dashboard that pulls together a handful of critical metrics for each program and allows you to quickly compare them. So let's take a look at English. Lots of Google volume. It's actually growing. So we would anticipate growth in this program moving forward. We're not actually seeing that growth. It's very large. There are 516 students enrolled here. but it's dropped down 16% or 16 students, excuse me. So we're seeing a decline despite growth in the market. And that might well be worth looking at before it gets out of hand. It's a very big program. So declining enrollment when demand appears to be increasing is something you'll want to have a close look at. We're getting a lot of revenue from it, as you'd expect. My cost per student credit hour is $91. It's green because that's actually a very good number. It's $4 below the benchmark. So if anything, in this particular program, we're looking at potentially needing to increase resources. We're running below benchmark on a program that has a lot of students in it. So that could be a concern, especially for something like English, where a fair amount of personal attention is needed in order to, for example, grade papers. Physics is a very different story here. You can see a lot of pink on the physics line. The Google volumes are down. Job postings are almost non-existent at 6. Enrollment is very low at 17. And if I look at my cost, this is actually good news. My cost per student credit hour at 219 is one of the higher ones on my campus. That's why it's orange. But actually, it is below the benchmark. So it's running efficiently, even though it's a very small program. So that's a couple of examples of the kinds of dashboards that you'll want to be able to have to be able to understand your programs both individually and as a whole, as a portfolio. Now, from there, you're going to go on to predictive analytics. And in this case, what you can do is actually build models that will predict the size of academic programs. And that requires a whole bunch of data about the market. You've got to go in and engineer individual factors so that they are more predictive. Things like competition tends not to be very predictive as a raw variable, but when you engineer it, you can get it to be highly predictive. And then all sorts of public data out there, census data and so forth, that can be built in a first cut prediction. In particular, in this case, by zip code. Then you've got to, so that'll allow you to predict how big any given program is going to be in the abstract. Then you got to make that institution specific and award level specific. And so in this case, what we've done is use a layered model and created an ensemble model prediction that gets pretty accurate, actually. When we ran this, we could predict with over 90% accuracy whether a program that we said was large would be large or medium. So in effect, what we're doing is significantly reducing the risk of a disaster. That is a launch of a program that you expect to be large, it turns out to be small or very small. Only 3% odds that would take place. So again, very substantial reduction in risk.
Bob, may I stop you for a moment? Do you have time for 2 questions?
Sure.
So the first one is for the program portfolio management. Are you using just enrolled majors per program or credit hour production? I asked to determine if or when to include general education credits per depth of program.
In our systems, we keep track of both and other metrics as well. So both are important. It depends what you're trying to evaluate. When you're looking at, for example, productivity, credit hour production by faculty members, knowing your student credit hours becomes an important dimension of that. Knowing the student credit hours in a program typically is what's going to drive the economics of the program as well.
Great. And our next question is, where is the Google data available? Is this published for Canada as well?
Yeah, you should be able to get it for Canada. What we're looking at is Google Trends. Is that if you literally Google Trends, you'll find yourself on a page and you can enter keywords and see the volumes. Well, what you'll see is the change in those programs over time. It's indexed. So that's not very helpful to the average mortal in its raw form. It'll tell you whether a program is trending up or down, but not absolutely how much volume there is. The way you solve that is pick some keywords for a program that you know well, and then put that in with the program keywords that you're trying to compare. And ideally, you pick a program where your marketing department can actually go in and find a keyword search volume for that program right now. And that allows you to use the index numbers and know how many actual searches there are. That sounds very complicated. It's really not. Let's say you have a program, your marketing department tells you that you've got 1,000 searches for a given keyword for that program. You put in your second program, the new one that you're looking for, and it comes out half as tall on that chart as your base program. You know it's half as many as 1,000. It's got 500 searches, and you'll see the trend over time. So that comparison of one you know with one you don't know allows you to use Google Trends and get hard numbers out of it. Now, there's another dimension to this that I think people are going to start to try and pay attention to. And that's when you start to step away from individual programs and look at your portfolio. And what we've started to do is apply techniques from financial markets to be able to smooth out the volatility of a program portfolio. So in this case, you can see respiratory care therapists has done pretty well over time. We've gone up from 800 to 1,600 programs. But it's been a little bit of a rough ride. We've had times when we grew very rapidly, then flattened to decline, then rapid growth, then a decline, and then another growth period. It'd be nice if we didn't have to go on that roller coaster. And what you can see here with cognitive science is actually at the same time that respiratory therapy was going down, cognitive science was going up. So if we combine those two programs in one program portfolio, we smooth out the variation a great deal. Not completely eliminated, we've still got a little bit of a bump here, but certainly reduced. The other time to think about this is looking at your current portfolio and seeing if all the programs are correlated. That's very risky. That means that they're all going to go down at the same time. And that really is potentially an issue. And finding ways to diversify into different sectors so that you can reduce the volatility of your overall portfolio can be quite helpful. An example here is think of liberal arts colleges that are focused really in what's right now kind of an out-of-fashion space. And for those that haven't already diversified, it's very problematic. And you can see some who've made the move and started to launch programs or have programs like nursing that smooth out what I hope is a temporary dip in demand for liberal arts. And that's a long discussion for another day, but there's a lot of mistaken data about liberal arts and its attractiveness as an academic program. As a history major, I take umbrage at it, but I won't take too much of your time with that today. This may look similar, but it's actually highlighting a different issue. The other thing that you got to watch out for with IPEDS data, but also a way of thinking about things is oftentimes you'll see programs that cannibalize other programs. In this case, economics, you can see got eaten by econometrics. Now, by combining both those programs that you see, they actually did manage to grow. But econometrics appeals in particular to international students, and it also has attractive characteristics in the new payout scheme that they have in California for funding higher ed, because it's a STEM program. So all sorts of students would prefer to be in a STEM program, and it pays the university more if it is a STEM program. So you see this big shift. It's somewhat artificial, but not entirely. And in particular, I mentioned international. International students who come to a STEM program get an extra year on their visa. So it's much more attractive for them to come in to a STEM program than to a non-STEM program. And that resulted in this dramatic shift. Now, if you'd stuck with just economics through this period and hadn't cannibalized yourself, I think you'd have seen a decline in volume for economics. By offering econometrics, yes, you cannibalized your own program, but better those students are still at your institution and not someplace else. Now let's switch over and talk a little bit about DEI. I'm not going to spend a lot of time here, but there are fundamentally three places where diversity can get impacted and the opportunity for certain groups can be reduced. And in particular, we're going to look at income loss. And first place is they don't go to college at all. And they're not represented in your admissions pool at the same level they're represented in society. And when we look at that in the aggregate across the country, it allows us to understand how much income is lost because a group is not attending college in the first place. The next place we see a big economic impact is program selection, which varies a lot, as I mentioned earlier, by demographic group. And then finally, some demographic groups graduate at a higher rate than others. You combine all those and you can begin to calculate the equity opportunity, that is the amount of additional income these groups could earn if they'd successfully completed college in an appropriate program. Why this happens, I don't know, and please don't mistake me for endorsing this, but it is true that women and minorities, except Asians, tend to over-enroll in programs that have low income. So in this case, we're looking at programs that have under $80,000 in income, and you can see the male students are much lower than the average in that, Asians much lower than the average, female, Black, and Hispanics well above the average. So I mentioned this demographic skew. This is persistent across a number of programs. There are groups who for some reason feel uncomfortable enrolling in programs that have higher income. By the way, most of those programs are either going to have a technology focus or a highly analytical numeric focus, which may be what's driving this, but nonetheless, it really harms these groups not to be participating in those other programs at an equal rate with others. It's not that the programs are bad, but I don't know why these groups should disproportionately be enrolling in programs that pay less. So if we track that concept through, we're going to look at Black men and Black women in particular. For Black men, the big part of the opportunity is actually enrollment. There's a $6 billion annual loss of income in the United States because Blacks don't enroll in college at the same rate as other ethnicities. Graduation rates also lower, 34.8 versus 69.9, or almost 70% in the general population. That costs another $3.7 billion in lost income. Program mix, it's still almost $1 billion, but much less. And overall, we're looking at a $10 billion annual loss in income because we're unable to get Black students into college, through college, and in the right programs. Very interesting difference when you look at Black women. Here, they actually do enroll in college slightly above the national average at 7.4%. But we have a similar problem with graduation rates, which is costing us $4.5 billion a year in lost income. And program mix, as we mentioned, women and minorities and Black women, of course, combine those two, over-enroll in programs that pay less. So here we see an opportunity cost of almost $6.3 billion as a country. It's a lot of money to lose every year because we can't figure out how to get students into and through college. And each college can look at these metrics on their own. We've actually built a database so you can see your own results if you would like to, and understand both what the potential impact is of addressing these issues, both for the students and also for the college, since under-enrolling in these groups actually damages revenue for the college as well. Now, let me just take a moment and share with you AI in action. And let me switch screens here. And, the traditional way of getting data, I mentioned it's going to get pushed out to you. But if you have to go get it, you'd have to understand the system and do a bunch of filters and do a lot of work to try and get the data out of the system that you're looking for. On the other hand, when you take AI tools and run them, as soon as my software comes back to life here, it'll take me a second, you can skip a lot of that work. So I'm going to do here is just ask a question. Or let me just ask it to rank margin by academic program. And then I want to pick a given and for 2021. Now it's going to pick calendar year 2021 when I do that. So now it's going out, pulling my data, and it's ranked all my programs based on contribution. And it's given me a couple of charts to look at as well. So here again is a ranking. And here I've got it split by year. It took me literally that long. And if I wanted to switch this to academic year, I believe I can type that in. And I'll just go grab it over here. And I can select 2021. And I can say rank margin academic program for 20. And it should pull that correctly now. Not giving me the prettiest charts this time. So it's really that easy to come into the systems and begin to get what you want in real time using natural language. I think it's a real breakthrough in terms of ease of use, especially for those infrequent users who might need to get into a data set. So that's my portion of the presentation. Let me hand it off to Rachel, and she'll talk through other applications of AI in the academic program evaluation space and in college in general.
Bob, one quick question, if you don't mind. For the University of California example, was that for one of the 10 campuses or all 10 campuses?
I'm going to say all 10 campuses. I'm not positive, but I believe it's all 10. All right, I'm going to stop sharing. Rachel, do you want to share, or would you like me to click?
I can share. I didn't know.
I'll keep going. It's all right.
You
Just
want
tell
me-
me what
okay.
you like.
Okay.
All right.
Well, thank you, everyone. So thank you, Bob, for having me. So I want to say a little bit about how AI is sort of pervasive in our everyday life and how we can brainstorm about how to use AI for program evaluation in the future. So everybody talks about ChatGPT. Everybody talks about all these large language models that's really popular right now in the news. But the reality is AI is everywhere in our life. It's not just ChatGPT. I will actually challenge everyone to try to go through a day without using any AI. You will find that it was probably possible 30 years ago. It's getting increasingly difficult to navigate your life without AI. So your Alexa, your phone, your Google search that does not only search, but also completes your search, gives you options, your GPS, your Netflix recommendations, all these robots that are trying to dominate the world, and all these different pop-ups that try to verify if you are a real human versus a person, face recognition on Facebook and many other devices, your Roomba, and really AI lives on your computer. It's everywhere. So in conventional programs, we have been doing analysis for program evaluation for many years, and there are lots of things that we do really well with traditional analysis. And some of these analyses can be considered as AI next. So we can think about how these conventional programs are different from AI. And if you think about, we have been using computers for many years already, and they actually do very well. But most of the programs that we use that we don't consider as AI is what we call rule-based systems. They're really good at setting up a rule, and then you will be able to automate the process of executing those rules and monitoring those rules. So for example, you may have a rule that's will give scholarship to anybody whose family income is less than $50,000. That's a rule that you can program into the computer very easily, and the computer will execute that rule for you very accurately, right? Very reliably. However, AI is also leveraging computers, but in a slightly different way. So instead of providing a rule to AI, what we want AI to do is to discover that rule. So for instead of setting up a rule by an expert, so an expert might do a lot of research and decide, you know what, the best threshold is $50,000. Instead of that, what we can do is have AI analyze the statistical patterns of your data and then come up with a threshold that may be 50,000 for one group, 54,000 for another group, and that threshold can shift over time depending on the data. So instead of us providing rules, AI can discover and utilize these rules for us.
When we were talking about this the other day, you mentioned that AI in effect could look at historical enrollment by student and then be able to estimate how many students are likely to enroll next semester in, Philosophy 104. Is that practical? Is that doable?
Yes, definitely. So if AI can complete your search sentence of phrases, AI can definitely, it's basically predicting the probability of your next word, right, in auto completion. So you can definitely train an AI model to predict what students are most likely to take in the next semester. So this is a big distinction I want everybody to sort of keep in mind as a framework as we move forward, right? So automated execution of rules that humans provide versus automated discovery of patterns that's done automatically by AI. Many different branches, different types of AI. So language is definitely one that's very hot right now, but let's sort of take a look at the broad categories of AI that is very common. And actually, these are all pretty mature technologies right now. So a big umbrella of AI is called learning. So a lot of the predictions that Gray is really good at doing is actually considered learning algorithms. You're learning from the historical data from the past and try to predict the future. So prediction, classification, those are trying to classify your students into those who will enroll versus those who will not enroll. That's will be a classification problem. Predicting the likelihood of taking a course or continue, those are all predictive models. So these are actually all considered learning tasks. And if you have heard of deep learning, then deep learning is actually a lot of that is actually to do these prediction and classification. The traditional regression models are what we call shallow learning. It's running the model once, maybe a couple of times, whereas deep learning is running these models repeatedly through a neural network. So very similar goal is always either trying to predict a number like revenue or a class or classification, which is the is the students go to choose option A or option B. That would be a classification problem. So you can use traditional methods to do these prediction and classification, but you can also use neural networks to do the same thing. However, neural networks allows us to do other tasks or beyond predicting a number or classifying a number more efficiently. So in the domain of vision and language, you really need a deep learning neural network to perform those tasks. There's also a lot of unsupervised learning, so clustering, dimension reduction. Those are very common in traditional methods. They are also key elements for recommendation systems.
Well,
Reinforcement.
I think for admissions and things like that, clustering becomes important to be able to identify similar groups of students who may need to be marketed to or spoken with in a different way. What does the cluster of students look like that's going to end up in a philosophy program, for example? Probably predictable with data that folks haven't collect during the admissions process. I'm not sure to what extent that's used right now, actually, to do those predictions.
Right. So that's a very good example. And if you can also think about clustering in two separate domains. So you can cluster your students into different groups, but you can also cluster your programs or classes into a separate group. So you have two sets of clusters, and then you can do matchmaking, and that becomes your recommendation system.
And classes, of course, could fit in a recommendation system like that as well.
Yes. So the third category of learning is what we call reinforcement learning. They're a little different from all these other categories because reinforcement learning is about trying to optimize a long-term goal after a sequence of actions. Usually at each step, you will get some sort of feedback from the environment. Yes, you're making going in the right direction. No, maybe you're losing a couple of points. So it is for something that has a sequential nature. So it's really, it's used a lot in planning. And these things traditionally in AI are used in games. So a lot of video games is a lot of little steps, right? And you're earning points along the way towards an ultimate goal, which is to maximize your rewards or your point system. You can think about the stock market as a giant reinforcement learning exercise as well. You're making a little bit of money one day, maybe you lose a little bit of money the next day, you do buy and sell, you take these different steps. And every time you do something, you get a little bit of feedback, but you don't really know if you're going in the right direction or not. It really takes many different steps to figure out your long-term reward. It's used a lot in robotics. So if you want your robot to navigate, your Roomba to navigate your house, you cannot actually supervise or give your Roomba a correct answer. The Roomba really have to learn from trial and error, from navigating your living room to be able to figure out if it actually has succeeded or not. So if you think about those algorithms and try to apply them in the program evaluation space, there are actually a lot of potential opportunities for taking advantage of reinforcement learning. So identify tasks that are sequential in nature. For example, if you need to do your long-term financial planning, what are the many steps do you have to take year by year, or month by month, or even day by day to be able to maximize your financial return? You may want to minimize your cost over time, but in order to do that, you may have to figure out what should I do in semester 1, semester 2, semester 3, and so on and so forth. So you can do planning for the institution, you can do planning for course offerings. You can also make an automated plan for the students as well. And all of these algorithms use optimization and search, and I have some examples to show that later on. In the space of program evaluation, a lot of these techniques actually have been applied already. So if you think about natural language processing, I believe Gray has done some innovative analysis of program sort of text or document language data from programs, and also language data from the skills that employers want, and do a matching between the two spaces.
Mhm.
There's also financial optimization. There is location scholarship optimization. I believe Gray has done some really, really good analysis on, and these are all different ways to leverage optimization algorithms. Of course, the traditional prediction models for program size, revenue, enrollment are all excellent examples of AI. So do not forget that AI actually encompasses a lot of things we already do. What I want to use today's time for is to illustrate some probably less common examples of a program evaluation that maybe we can leverage AI for. So these are sort of ideas that I have brainstormed, and I can see that these can actually be easily implemented by your institution if you can find some smart PhD students and a good data set from your institution. So I'm going to spend some time talking about vision, language, natural language processing, and a few other ones.
Great.
So if you click through, I'll probably highlight a few other ones. Yeah, recommenders and planning. Okay. All right, so a couple of examples. So natural language processing is like what Bob has illustrated, has a really, really intuitive user experience. People like to interact with AI using natural language processing. So, and now that the language models are mature, there are many, many opportunities for applications. So one is sentiment analysis, which actually has been done for many years already, but because data are being collected over the years, there are many opportunities to apply sentiment analysis both within and outside your institution. ChatGPT, of course, there are many, many different potential applications. With computer vision, I'm sorry?
I think that sentiment analysis, what I don't think I've ever seen is sentiment analysis by academic programs. You probably have people in your organization already in marketing who are looking at sentiment analysis for your brand. If they're not, they probably should be to see what's out there and what folks are saying. But there probably is shifting sentiment about what academic programs to pursue as well, that you could keep track of on the web if you were in the right student sites, if you will.
Well, and also it's probably hidden in your course evaluations.
Good point.
So application of computer vision, actually there's some very mature applications for grading. So Gradescope is a very popular tool right now for grading handwritten homework assignments. That's very common in chemistry and biology and calculus, math, where students have to draw things. So if you think about if you have to analyze the content of your syllabi, Blackboard, documents from your students, from your professors, there's probably a lot of hand drawing or diagrams and visual illustrations that cannot be handled by language models or just recognizing words, word processors, but instead, maybe you can use your computer vision techniques, which is very mature these days. They're very, very simple tools that you can use to very quickly sort of process and understand the diagrams and the visual tools that's being used at your institution. Recommendation systems, so I got this graph from a financial presentation that matches, do recommendation systems but to match investors and companies. And you can think about how to easily leverage these recommender systems that you see now on Netflix, on Amazon, and in other domains. You can easily think about how to leverage a recommendation system for advising, for example, to sort of help improve the process of planning and delivery of your curriculum. And finally,
aligning students both with what they're likely to be successful in, as well as what they need to do in order to graduate. Both those exactly be visible to the AI system when they do these recommendations, if you do it right.
Exactly. Yes. Yes. And the last illustration is very small, but it is a plan that is generated by AI. So AI can look at the data from a variety of sources and generate an optimized plan for, and this is a financial plan for, like, you should do this investment first and then this investment and next investment, so on and so forth. And you can think about applying the same technology to make a plan for your students, for your advisors, for your departments, for your programs, and also for your institution. So yeah, so these are the 5 different AI examples that I'm going to look at. So ChatGPT, if you think about ChatGPT, it is a large language model that has been trained on the internet. And that is basically all the publicly available data that's out there, which is great. And that is why it has an amazing result, but it does not see information that's private to your institution or to a certain specific domains. And so for AI to really perform very well for the specific domain that you care about, you really need to train these models on domain-specific documents. The good news is that a lot of these large language models are publicly available. They're pre-trained, because the most difficult part is actually training the model. And a lot of times they take months and months and months to train. Not many companies can afford to run a training process that takes like 8 months. It not only it takes time, it also takes a lot of expenses to have these many GPUs to continue to run data for you. So we're very fortunate that in the public space, there are a lot of these pre-trained models that are readily available for you. And what you can do is leverage these models on data that's private to you. So one of these examples is Bloomberg GPT, right? So Bloomberg trained ChatGPT on their own financial data and came up with a product called Bloomberg GPT. And Bloomberg GPT is effective because it is trained specifically on the data from the financial domain.
Rachel, we're running down to our last 5 minutes.
Okay.
Any place you'd like me to go?
Let's just go to the next. Let's just look at the next couple of slides. Okay. So think about combining ChatGPT.
One sec. It's pretty scary as an institution when we say, you can put your own data in ChatGPT. What happens to confidentiality? To what extent is your data walled off from the world?
Right. So you want to have your own version of these things and run it on your own computer. And there's a whole domain of federative learning that is that's all devoted to handling privacy and confidentiality. So it is doable at a technical level, and you definitely want to have some AI experts on your team to make sure that happens. So next, let's take a look at a couple of examples.
You want to be,
Yeah, just go. So this chat GPT, if you combine it with, for example, your own syllabi data, you may be able to, and all these documents from your Blackboard, you might be able to come up with your own advising GPT, right? And pick your own GPT, whatever data you want. So take an inventory of the internal assets, external assets, data assets that you have. These are things that you probably already have publicly available sources, Rate My Professor, College Confidential. Because of the language models are available, you can take advantage of all this text data and try to see if you can get some sort of pulse on the chatter that students are having externally, so that you can get a better sense of the market demand for different programs.
Let me interrupt you just 1 second, because we have a statement that one of our guests would like both of you to weigh in on, and that is there are a lot of problems with student course evaluations.
So in terms of representation biases or reliability, I am a professor, so I am constantly concerned about the fairness of course evaluation. So definitely AI is trained on data. So we have all heard garbage in, garbage out. So of course you want to make sure your data is fair, your data is reliable before you train your AI. And course evaluation is no different, right? So of course, if you want to train a machine, a model that's based on your course evaluation, first of all, you need to make sure that course evaluation is something that your institution is willing to depend on.
yeah, I actually think AI presents a completely different approach to course evaluation. If there's a set of objectives for a program, I think AI is capable of looking at all the artifacts for that program. That would be what the instructor's materials, the students' written work, even transcripts of classroom discussions, and analyze that and assess the quality of instruction using the actual data from the program itself. That sounds crazy and like a huge lift. I'm not actually sure it is with current AI technology. I think it'd be pretty straightforward to get that running. So it may be a whole other way of evaluating a program that has much greater objectivity than a given set of students might have who are having a bad day when they fill out their survey, or may only be 5 or 10 of them in the course. And so you've got a statistically insignificant sample before you start.
Right, it may completely change the paradigm of collecting data on course evaluation and redefine, because you can automate so many things and you can make the user experience much better. You don't have to only sample student once a semester. You can probably do that many times.
Yeah.
So with that, I want to present this a framework for you to structure your thinking. So I want everybody to start thinking about your objectives for program evaluation, and then look internally and externally for data opportunities, what kind of data you have. And then by combining the data and your program evaluation goals, you may be able to come up with different AI solutions.
Great. Let's look at one example. Just looking through here to pick one that may be helpful.
Okay, so for example, perhaps you want to produce personalized.
Which one would you like?
Well, this one, if you go one step back.
Okay.
Okay, so perhaps you have your goal is to do career planning, and you have job and alumni data. And if you can feed that into train your ChatGPT on jobs and alumni data, maybe you can come up with a virtual career coach app that can help your answer specific questions about your students and make recommendations for jobs and connections specifically based on your own data set.
Cool. Well, thank you very much. And thank all of you for joining us today. I think we're at the top of the hour. I think both Rachel and I are happy to stay on and answer any questions if you have them. So please feel free. And remember, we always have a variety of different ways you can interact with us. Our webinars are free. We have 2 coming up this week, one for community colleges and another for 4-year colleges and graduate schools. The book is out there. Buy it on Amazon. It's a great way of figuring out how to evaluate programs. Not that I'm biased or anything. And then finally, we have a course, actually, if you want to really get in depth on how to evaluate academic programs, we offer a course through Baypath that you can enroll in. Thanks again, everybody. I hope you enjoyed today's session and beginning to think about how we take some of these very powerful tools and apply them to program evaluation.